In this lecture, we want to look at how the day affects the direction of sunrise and sunset. To find direction by the sun, you first have to understand how it works, where it rises and sets, and how it moves across the sky. Most people, I suppose, think the sun rises in the east and sets in the west. And it does, for 2 days out of the year. The rest of the year, however, it rises somewhere north or south of east and sets somewhere north or south of west. How far north or south of east it rises and how far north or south of how far north or south of west it sets depends on two factors: the date and your latitude. Looking now at how the date affects the direction of sunrise and sunset, we'll say it's March 21st, 2015, and it is 6:20 a.m. The program that I'm using here is called the Neve Planetarium. That's Neave, and it's available online. And it's an excellent planetarium program for coming to understand the workings of the sun, the stars, and the moon. So here we are before dawn on March 21st, 2015, and as the minutes tick by, let's see what happens to the sun. You can see the stars moving across the sky, and here's the sun coming up, and it's going to come up this day due east. So there the sun comes up on this day called the Vernal Equinox. It comes up due east and then, of course, travels on through the day throughout the sky. Looking now to the west before sunset on this same day, March 21st, 2015, we're going to see that the sun is going to set due west on this day. So you can see the sun coming down, approaching the west, and there as it crosses the horizon, the position of the sun is due west. After the March equinox, with each passing day, the sun rises a bit farther to the north of east and sets that same bit farther to the north of west. Finally, on the June solstice, on or about June 21st, the sun rises as far to the north of east as it will ever rise and sets as far to the north of west as it will ever set. As we talked about, each passing day after the vernal equinox, the direction of sunrise and sunset drifts to the north until we come to the summer solstice. And here we are on June 21st, we'll say the year is 2015, the day of the summer solstice. On this day, the sun will rise as far north of east as it will ever rise. So let's just watch the workings of sunrise. Here it is right here. You notice how far north of east it's coming up. And so the day following this, the sun will come up a little bit closer to the east, and it will continue to come up closer to the east until we get to the autumnal equinox. But I wanted you to be aware of the fact that on June 21st, the summer solstice, the sun will come up or will rise as far north of east as it will ever rise. And here is sunset on that same day, June 21st, 2015, and you notice that it sets to the north of west. So however far it rises to the north of east, it sets that same distance to the north of west. So now we'll fast forward a bit to September 23rd, the day of the autumnal equinox. The equinox falls somewhere around September 21st. In this case, the specific date is September 23rd. So you're going to see the sun rise once again due east. So here's the sun coming up right there, due east. And on that same day, it sets due west. And here we are that same year at the winter solstice, which is on or about December 21st, in this specific case, December 22nd. And so we're going to see the sun rise to the south of east and set on that same day to the same distance to the south of west. Then back once again to the vernal equinox of the following year, and the sun once again comes up due east and sets due west. At this point, if you live in the southern hemisphere, you may be saying to yourself, well, wait a minute, Reed. In the southern hemisphere, our seasons are just the opposite of yours in the northern hemisphere. Is what you explained about sunrise and sunset, does that still apply in the southern hemisphere? And the answer is yes. In the southern hemisphere, just as in the northern hemisphere, on the June solstice, the sun still rises and sets as far north of east and west as it will ever rise and set. And on the December solstice, it still rises and sets as far south of east and west as it will ever rise and set. And of course, on each equinox, whether you're in the southern or northern hemisphere, the sun still rises and sets due east and due west. The seasons, of course, are reversed, and the names of the June solstices and the December solstices are reversed, as are the names of the March and the September equinoxes. They are reversed. But the direction of sunrise and sunset remains the same, whether you're in the northern or southern hemispheres. Let's now sum up what we've gone over in this lecture. The direction of sunrise drifts with the seasons. On either equinox, the sun rises due east. And on the June solstice, the sun rises as far north of east as it will ever rise, and on the December solstice, it rises as far south of east as it will ever rise. So this continuous drifting of sunrise and sunset takes place throughout the year from north of east to south of east and back to east again. Sunset works the same way as sunrise. On either equinox, the sun sets due west. Then on the June solstice, the sun sets as far north of west as it will ever set, and on the December solstice, it sets as far south of west as it will ever set. Now that you understand how the direction of sunrise and sunset drifts annually through the seasons, you're now ready to move on and learn some more stuff about the sun that will help you find directions to within about 10 degrees or so. So let's now move on to the next lecture and learn some new stuff.